Welcome back to Architecting in a Complex World. Our last presentation today is Uncovering Architectural Challenges in a Systems of Systems by Mike Gagliardi. Michael Gagliardi has more than 25 years of experience in real-time, mission-critical software architecture and engineering activities on a variety of Department of Defense systems. His current work involves the development of architecture evaluation methods for systems of systems architectures and system of system architectures. Mike is joining us from Washington, D.C., so let's get a quick sound check. Mike, you there, and how are you doing today?
Yes, I'm here. Thank you very much. Appreciate setting this up.
Okay, all yours.
Okay, so I'd like to thank everybody for attending and giving me the opportunity to share the work we've been doing recently in system of system architecture, specifically uncovering and identifying architectural challenges in a system of system, and we'll find that there's other challenges that also get uncovered. Just to set a little bit of the context that we all know, been working in this field long enough, that functionality and capability are king when it gets to a certain level of management. But as we've heard today, and we're going to hear again, the architecture must be driven by the quality attributes in addition to the functionality and capability. This is true in a system architecture and a system of system architecture. So being able to specify and address the quality attributes early and evaluating the architectural decisions and identifying risks is key to the success of any endeavor, and this is exacerbated in a system of system context. And as we've seen before, and we see it also in this context, that without paying due diligence to the important architectural drivers, the quality attributes, significant integration and operational problems will arise due to inconsistencies, ambiguities, and architectural mismatches between constituent systems, legacy systems, and what is needed by the system of system architecture, knowing full well that these system of system are not going to be greenfield. They're going to be comprised mostly of legacy systems, and they're fairly large systems. Some examples of quality attributes that we're talking about, and it runs the gamut of all the ones you would see in software, but there's also some new ones we've uncovered when we stretch out our scope into the area of system architecture and engineering and system of system architecture and engineering, spectrum management, force modularity. These are just some of the examples of quality attributes that we've run into when we start looking at system of systems and system architectures. So when we first got underway, basing all of our work on the fundamental architecture tenets that were developed by the SCI for architecture specification, for software architecture specification and evaluation, we realized when we started looking at the SOS architecture domain, especially in the DoD, we noticed that there's DoD does through via DODAP. They support a good set of architectural views for an SOS architecture. However, it was pretty clear that it was inadequate for addressing a lot of the cross-cutting quality attribute considerations that are going to arise in a system of system architecture. And when you look at the proliferation, and they're very good at coming up with system use cases in that domain, however, it only looks at a functional slice of the system. So it became clear to us that more than just what was expressed in DODAP and system use cases was needed to ensure that a system of system architecture satisfies its requirements and its cross-cutting quality attribute needs. So we identified the system of system end-to-end mission thread as the vehicle by which we can reason and actually from which we can augment those threads with quality attribute considerations that are going to help drive and define the system of system architecture. And then later, they're very useful, just like quality attribute scenarios in software are very useful for expressing what is needed from a quality attributes perspective. They're also very good at helping the evaluation process to identify any architectural risks or architectural mismatches, whether it's at the SOS level or the constituent system level, as the thread winds itself through constituent systems in trying to achieve its end-to-end goals. So a little bit of a definitional chart here. We define a vignette as a nice description of of the environment and the geography and the structure and for example, in the DoD context, what are the enemy forces and what are their attack strategies. It's kind of a nice overview and sets the context for one or more mission threads that are going to be used to execute that vignette. And we found those to be very useful because they tie in very nicely to OV1s in a DODAP context. The next definition is what we call the end-to-end thread. We got this from the C4ISR for Future Naval Strike. An operational thread, mission thread, is a sequence of end-to-end activities and events beginning with an opportunity to detect a thread and then ending with an assessment of damage. And we found that that was a very good definition for an end-to-end mission thread in an SOS context. What we discovered after we've been through a couple of mission thread workshops, and we'll describe that in a second, that you need more than operational mission threads. You're going to need to have some kind of sustainment type threads, development threads, and actually acquisition type threads, because when you know you're dealing in a context where the constituent legacy systems are programs of record themselves, and there's going to be some acquisition issues involved in how is this going to play out in the system-of-system context that the threads talk about. So we define operational, sustainment, development, and acquisition type threads. Initially we didn't, but then we found it to be useful to decompose it into those 4 types of threads. So let's give an example wording. What do I mean by a vignette? So in a context of a kind of a naval excursion out at sea in a theater somewhere, you have 2 ships, we'll call them Alpha and Beta, and they're assigned to some integrated air and missile defense capability to protect the fleet, which contains some high-value assets. A surveillance aircraft, SA, and 4 UAVs are assigned to the fleet and controlled by the ships. And 2 of the UAV are flying as a constellation, which can provide fire control quality tracks directly to the 2 ships. And then what happens is a 3-pronged attack on the fleet occurs. A lot of things are being go on at once as we're going to spike up together, or very close proximity from a timeline perspective, where 20 land-based missiles are shot off from the east. 5 minutes later, 5 aircraft-launched missiles are shot from the south, and 3 minutes after that, the submarines start launching their missiles at the high-value assets. And the fleet is protected with no battle damage. So that's an example, and it's been sanitized and watered down a little bit, but that is an example of a vignette, a fairly well-structured, concise vignette, from which 1 or more mission threads can then be developed. And let me go into that next slide here. So if we take the context of that vignette, and these are non-augmented, we haven't put the quality attribute augmentations in there, but it is a starting point from which we're going to talk to about how we deal with that and how we're going to get some architectural challenges from this exercise. So you can see that end-to-end thread is you can see steps 1 through 5. I'm not going to read them all out to you, but you get the gist that there are some major activities that are going on in this thread, and it involves lots of nodes, lots of actors, some capabilities, and you also notice in the verbiage that performance might not be well represented here, or availability might not be well represented, but that's okay, because when we get to the mission thread workshop, we're going to talk about how we augment these very important mission threads with quality attribute considerations, which will then drive the architectural decisions that have to be made, whether it's at the system-of-system level or at the constituent system level. As you start thinking about, I want to use a particular system, a legacy system, maybe a radar or a gun or a launcher, in this context, and it might not have been designed in that context originally. So this is an example of an end-to-end mission thread. We try to keep them, below 20 or 25 steps. And most of the entries here are major activities that have to be dealt with by the architecture. So let me take a step back and show you some of the methods we came up with when we started putting this together. So, the basic idea is to do early elicitation of quality attribute considerations at the SOS level, and then those can drive down into constituent system levels as we start looking at each step in the threads. We want to be able to achieve some early candidate legacy system architecture evaluation. What we're trying to identify real early is any architectural mismatches between the constituent systems as they're considered to be candidates for inclusion in the system of system architecture. A lot of times there's capability analysis being done at the thread level, but what we're looking for in addition to that are the engineering considerations and the architectural considerations for their inclusion and what you have to do about it, what we propose to do about that. And that's what happens in the blue box called the Mission Thread Workshop. And inputs to the Mission Thread Workshop are SOS mission and business drivers, vignettes, and mission threads, which I gave you an example in the prior two slides, and whatever level of SOS architecture development and planning that you have in place. And it's very early in the life cycle. Pre-milestone A is when we really want to get involved in this. Have a nice good ConOps too is good. And an output, the two main outputs of the Mission Thread Workshop are augmented mission threads. What I mean by that is that we get the stakeholders together and we start going step by step through the mission thread, and looking at the assumptions, looking at the steps, and considering all the quality attribute considerations, issues, questions, unresolved issues that we document as we get the stakeholders together. And a very important piece of this is using the mission threads to identify which SOS and constituent system stakeholders should be at this strongly facilitated workshop we call a Mission Thread Workshop. And we're going to go step by step through that, and we're going to look at the mission thread steps, the assumptions, the nodes and actors, and we are also then going to take a look at the overarching quality attributes and document all the considerations, all the issues, all the challenges. And a lot of times, as we've seen, we've done many of these now, that sometimes it's the first time all the major stakeholders have gotten together and really looked at this from an end-to-end perspective. And as you can imagine, lots of questions come up. Some are architectural in nature, some are engineering and capability in nature. So the two outputs of the Mission Thread Workshop are the fully augmented mission threads with the quality attribute considerations and a set of SOS architecture challenges. And once you've done a series of them and you've gone through all the important mission threads, what we recommend is you use those threads and outputs to identify the candidate legacy constituent system and software architectures and use some of the use cases that come from those discussions and those augmented threads to do an architecture evaluation to look for any architectural mismatches or capability mismatches for the candidate constituent systems. So let me go on to the next step. So let me talk now specifically about the Mission Thread Workshop, which is where we're going to take the vignettes in threads, get the stakeholders together, and then we are going to walk through the mission thread in a facilitated manner and elicit for each event in the mission thread. So if you recall that mission thread example I had that it looked like maybe 20 or 25 steps, we have a template and we facilitate the meeting with the stakeholders such that as we go through each event in the mission thread, we start capturing and eliciting, asking some important quality attribute questions for each of the steps. Now, not every step has a performance issue, not every step has an availability issue, but that remains to be seen. It's actually very interesting when you start walking through the mission thread step by step and start asking some pertinent questions regarding the architecture, the quality attributes, or even the capabilities. It's amazing, especially when it's the first time a lot of people have gotten together to discuss it, how many issues you actually do capture. And many of them are engineering issues, some are architectural in nature, some are issues regarding the assumptions and some of the nodes and actors who are supposed to be playing out in this. The other thing we try to elicit is any additional use cases for each step. Sometimes you will find that there is a good set of use cases already, but they don't always have the quality attribute context. And a lot of times when you start asking some availability or performance or even maintainability questions or even reusability, it's amazing what you can find in a facilitated exercise like that. And we also capture any capability or mission issues that arise. So what we like to do is we go step by step through the mission thread, starting at the assumptions, and start asking and documenting all of the concerns and considerations that pop up. And it's not an exercise to fix any of the problems at this point. That's for a later time. We're looking to identify architectural issues, engineering issues, and then we take another pass over the mission thread. So there's basically two big parts to it. There's the step-by-step threads, and then what we call the overarching quality attribute considerations. There's a lot of quality attributes that get played out when you look at each individual step in the mission thread, but there's also some quality attributes and important ones that have more of an overarching consideration from, for example, availability, resource management, from a perspective of performance, what's the end-to-end timeline for this missile engagement. As you can imagine, there's a lot of overarching things. So we take two passes over it, and sometimes we get through the second pass in the quality attribute section, overarching quality, and we go back to the steps because some of that discussion triggered some very interesting things that go back to a step. But the bottom line is that we go through the mission thread step by step, quality attribute by quality attribute with the stakeholders. And you can imagine when you're dealing with a fairly large SOS, that there's a variety of stakeholders, and we try to limit it. You know, we use the mission threads to help identify which specific stakeholders we want. And if I can back up a second, we also strongly suggest a series of mission threads workshops, not a ton of them, but enough to get through the basic capabilities that are represented by the various vignettes. And we don't want to invite stakeholders to certain mission threads and waste their time if there's nothing germane to them. So we definitely strongly recommend a series of mission thread workshops. So when you're in each individual mission thread workshop, that's basically what we want to do. We want to make sure we go through it and in a very paying due diligence to all the engineering and quality attribute considerations that arise. The other thing that we do is, you know, sometimes there are paths through the mission thread that take a divergence, and we certainly don't want to spend a lot of time rewriting the threads. As a matter of fact, we go into these with mission threads that have been fairly well vetted between some of the, you know, the principal stakeholders in the system development effort, and sometimes we identify additional threads while we go through one thread, as well as identifying a lot of use cases that have to be dealt with at a later date. We're pretty strong facilitation from the perspective of we're not looking for any organizational issues, any programmatic or non-technical issues. We'll certainly capture those, but we're not going to beat a dead horse here. We're going to capture it, put it in a parking lot. But we're here the Mission Thread Workshop is here to identify SOS architecture challenges. And much to my surprise, when we first did the initial ones, there's a whole host of engineering, end-to-end engineering considerations that I was pleasantly surprised to see, I guess, at the time we first started doing these. The stakeholder inputs are key, and getting good mission threads ahead of time is key. So there's a lot of homework that has to be done before you start the mission thread workshop. So a pictorial representation is kind of like this, and let me walk through this whole thing. So the thread, there's a vignette portion to the mission thread, there's nodes and actors and assumptions, and what we ask is kind of inputs to the mission thread workshop is a nice set of OV1s, OV1 diagrams for the DoD folks out there. And they usually go hand in glove with the vignettes and the mission threads. There's a set of assumptions, and like I said, there's a steps 1 through N, and the augmentation is going to identify all the issues that come up and the use cases. And we found in some of our work to date that when you get a good set of nodes and actors and the assumptions are written down and vetted, you got a lot of fodder for a good OV2. And we found that in a couple instances that the architecture documentation really started to become normalized from that perspective when it was combined with the mission thread workshop. So you had a really nice set of normalized OV1s and OV2s coming out of the mission thread workshops. In addition to that, we found that it was very useful to take a lot of the use case augmentations and that we do inside. At least we take action items for people to do it as follow-on work to develop some really nice OV6s and SV6s. And again, that's true of whether it's an augmentation that happens on a per-step basis or an augmentation that happens at overarching quality attribute perspective. And from there, we have a mission thread workshop team that facilitates and documents what goes on, and we take a step back when they're done outside of the mission thread workshop, but immediately after that, and we kind of start looking at all the issues and start collating all the issues that came out, whether they're architectural in nature, engineering in nature, or capability, or what have you. And we start developing what we call a set of architecture and engineering challenges that derive from each of the mission thread workshops. And then we can, if you do a series of them, we roll them up into what we believe are the architecture and engineering challenges that came out of all the augmentation work and all the stakeholders' comments and questions that happened during a mission thread workshop. And what I have on this slide is basically what it looks like. It's all been cleaned up and sanitized for everybody. But as you can see, if you go down to the assumptions part, that we went in with a set of assumptions, and some were captured. But what the comments in blue italics were some of the things that we found, and this is by no means a complete list. It's just little snippets of mission threads we've done. You can see that in the second assumption, you know, they were in a naval situation, and the question was, were there sound buoys deployed or not? That came up in one of the mission threads, and it was an assumption that had to be dealt with and captured, and someone took an action item to go look into some issues about what would it take to get the sound buoys deployed, are they really necessary, and you can imagine all the engineering work that goes in after that. So this is kind of what the top part of a mission thread template looks like that captures the nodes and assumptions, and we start annotating where we found some issues during the workshop down in the assumptions. For example, there was a person at one mission thread workshop who represented the helicopter world, and he said it was the first time that he was invited to any of these meetings, even though they're a major player. So stovepipes happen. You know, I want to take a step back and say, you know, what's really one of the nice benefits of doing this is, you know, the reality is there's stovepipes in lots of large organizations, and some people don't always feel they have a say in what goes on architecturally or capability. This is a really great opportunity to break those stovepipes down, document what those considerations are, and have the voices be heard, and it's documented in the thread for further use in this SOS development. The next slide you'll see is a representation of what a step-by-step augmentation looks like, and you can see the right-hand column. We capture a lot of questions. Some of them are performance, some of them are capability, some of them talk about a known legacy system we call the defense engagement system that they really want to use in this thing, but when you start asking some questions on a per-step basis of what it can really do from a quality attribute perspective or even a capability perspective, you can see that there's some unanswered questions, and they're good questions and the questions that have to be dealt with. And then many of those answers to those questions are going to drive the architecture, and they may even necessitate a more detailed analysis or an evaluation of the legacy component or legacy system and software architecture to see what would be needed for it to actually to achieve the requirement that's kind of specified here, or at least the capability, whether it's quality attribute in nature, availability, or capability. So as you can see, and you can imagine, we usually have a lot of senior people there representing these various stakeholder perspectives, and take some strong facilitation to not dive into any of the details and get into problem-solving mode. Let's just agree that these are the issues, and we'll roll these up into challenges from which a lot of action items can be taken to help reason about some architecture decisions that have to be made. So that's what a step-by-step augmentation looks like. And the next slide talks about an overarching quality attribute augmentation. And I'm certainly not going to read all this, but you can imagine there's a lot of end-to-end performance questions. For example, you know, what is the decomposed timeline for this thread? You know, it's usually a really good answer, and it's very interesting how there's a lot of assumptions that people had about it, but it really wasn't vetted with all of the people and all the questions and considerations put on the table. The same is true for availability. That gets into kind of the distributed resource management. What happens if this fails? What happens? What's the reaction and what's the behavior of this constituent system in the event that something doesn't exactly go as intended, resources are exhausted, or things fail or get damaged? What is the distributed, or what is the SOS behavior? And as you can expect, there's a lot of unanswered questions, a lot of work that has to go into making those decisions. And what we found is very interesting. You know, we've seen lots of different stakeholders in these mission thread workshops, and invariably there's a group of folks, they're usually some of the high-powered FFRDCs that do a lot of system simulations and analysis and prototyping, and they are always busily writing down, taking notes furiously as to what could be proposed, or what are some of the simulations that they really should be running from an end-to-end perspective. That sometimes a lot of times people are just looking at the constituent systems and haven't really seen it from an end-to-end perspective. So you can imagine you go through perhaps a series of 6 or 7 different mission thread workshops, looking at 6 or 7 or maybe 8 or 9 different threads and augmenting them and getting all the stakeholder considerations. And the mission thread workshop team goes back and scours over all the augmentations and questions and considerations and action items and use cases. And what we like to do is we end up rolling up some SOS challenges. And what I have here is a list that came out of I'm not going to go into any detail about these specific ones, but these are common sets of things that we found by doing a variety of mission threads. One of them is invariably end-to-end resource management. Constituent systems have their own way of dealing with their local resources, and there's a lot of assumptions built in, and there's a lot of requirements that don't really look like the ones that that the system architect's looking at as far as behavior. So resource management, mission planning, readiness, situational awareness, interfaces, and there's a lot of, turns out that there's a lot of capability analysis that has to go on when you start really looking at what has to be done from an end-to-end perspective to get the right behavior, especially when you got a lot of legacy systems that you want to include. So we spent a lot of time as a team rolling up these challenges and presenting them to the group of the principal stakeholders there. And this is not a typical list that we find. For example, in the resource management one, you may be surprised, but in certain situations, especially early on pre-milestone A, not all the reasoning has been thought out about how do I deal with the total ship resource management, how do I deal with the true end-to-end resource management, all the behaviors and all of the idiosyncrasies that are coming along with the constituent legacy systems, and how am I going to deal with that? Do I negotiate? Do I talk to the program of record and negotiate? Well, now you have a basis. Well, we found that it's a really good basis to enter into negotiations and technical interchanges between the legacy systems that you want to include and the system architects who have to stitch everything together and get the right behavior. Mission planning is another one that we found to be very interesting, that they tend to be very stovepiped. And as much as people want to integrate their mission planning systems together, they're unfortunately, for a variety of reasons, it doesn't always play out well. So you end up in a system-of-system context with a lot of diverse mission planning tools. And when you take a step back and start looking at how you're going to put this all together and how you're going to do mission planning from that perspective, you end up finding a lot of issues that have to be resolved pretty quickly to get the right behavior out of this. So, and this all comes out of the discussions that happen in the mission thread workshops, and we start pulling these up to high level, either architectural challenges or engineering challenges or planning challenges. And as I said earlier, it was very surprising to me. I thought when we first embarked on all this, there'd be, we'd be looking at a lot of quality attribute, architectural big hitting issues, and we are. but we found an equal number, and this is true of just about all the mission thread workshops, an equal number of engineering and capability challenges from an end-to-end perspective that I was a little surprised to see, but it's very consistent, actually. The mission thread workshops we've done to date, how am I doing on time? The mission workshops we've done to date, we've done quite a few different mission threads. A big one for a naval ship, we did 37 different threads, and which required 13 mission thread workshops, but it did cover about 80% of the capability. We're very satisfied with it. And I did want to take a step back and say, you know, when you think about a mission thread workshop, it's pretty much a 4 to 6 hour exercise with a group of selected stakeholders that's strongly facilitated. But it takes a little bit of an investment, but I believe that, and people told us that the rewards are there, the benefits are there from an end-to-end perspective and a challenge, an architecture and engineering challenge perspective. It is an investment, but I think it's a very good investment, especially very early in the life cycle when you're starting making some, you know, especially pre-milestone A decisions with the program offices. We have a variety of different ones. As a matter of fact, we've done a couple in an enterprise architecture. I do want to state that we've done what we call business thread workshops in an enterprise architecture. Basically take the same idea and use it in an enterprise architecture, and it holds water very well. Matter of fact, we're doing one right now with the customer here in DC. So we've got a lot of experience to date. We have a lot of lessons learned. But I think that I'm supposed to stop at 3:45. Is that correct?
Mike, we got about Mike, we got about 10 minutes before we can start Q&A. Okay. So you got a couple more.
Let me go. All right. Thank you. Let me go into some of the lessons learned.
Sure.
So it's really critical to get the right mission threads. One lesson learned we had was actually the first one we did. We thought we would develop the mission thread with the stakeholders. It turned out to be an absolute mistake. You really got to sit down before mission thread workshops and hammer out and get a really good set of vignettes and mission threads. You know, they're going to change slightly during the mission thread workshops, but the idea is not to create the threads, but the idea is to augment the threads. The other thing is that you know, we're dealing with at the SOS level, especially, you know, one of the naval ship examples. It really was beneficial to decompose it into different mission areas and inherent capabilities, and we had a set of vignettes and threads for each one of those, even though they touch other areas. We found that to be a really helpful way of looking at what mission threads we really need in totality. And then as a group, we said, okay, here's the ones we're really going to do, and you know, these three. You take a look at, maybe you start with a group of them, and you say, well, the following four are very related to each other. Let's just make sure we cover that in one thread. There's not a whole, you know, very interesting. You know, we are the Software Engineering Institute, but when you do some SOS architecture work, you don't really talk about software that much. It was a little bit of a surprise to me. It's a good surprise, and actually, you know, as I mentioned earlier, the basic tenets of this: stakeholder-driven, quality attribute focus, document the architecture and concerns. It holds water no matter if you're at the system level or the system-of-system level. And we were pleasantly surprised that it worked very well in the SOS architecture domain. And we really did, you know, you really don't start talking about software until you start cracking open those inherent legacy system and software architectures. There is a little bit of a learning curve on what is a good mission thread and what's too much detail and what's not enough detail. And we found that once we get through the first one in developing the threads, we can pretty much hand it over to the principals in charge of the SOS architecture. And you know, they're smart people. Once they go through one mission thread workshop and get the hang of it, they come up with really good mission threads, as a matter of fact. It's really important as far as preparation that you probably pilot one, just so that the key stakeholders all get their feet wet and understand how it's going to be executed. And actually, in one case, we were able to hand it over. About the 5th or 6th mission thread workshop, we were able to hand it over to those folks, and we helped facilitate it. But you know, what you really need is a good set of quality attributes for the SOS should be defined. And that turned out to be a little bit of an issue, and it was actually a really good exercise to sit down with the SOS architects and say, okay, let's define what you mean by all these important quality attributes. Let's whittle them down. Let's get the business and mission drivers down. So there's a little bit of guidance there, and that could all be achieved by the first pilot. The SOS quality attributes, we noticed that this is the reason we created different mission thread types, is because when you want to talk about strategic reuse at the SOS level, extensibility, openness, those type of constructive type quality attributes, it usually ends up with a different set of threads, even a different set of stakeholders. We actually tried to do a developmental type mission thread with a group of operational stakeholders, and it didn't work out real well, and I had to apologize for even trying it. I probably should have known better, but those are the lessons learned when you're starting something new. But you know, you really got to split it up, and you're going to run into a different set of stakeholders, and those quality attributes have to be defined, and a good set of threads for each one of those. I mentioned before, you know, we always run into new sets of quality attributes from an overarching perspective, and here's a list here that I have on this page. Won't get any detail. I think I mentioned before that you know, the stakeholders are key, and they usually tend to be very senior people. And so you get the good set of stakeholders, get a good set of threads, and identify the necessary stakeholders. And you also need a core group of people who represent like the SOS principles. And it's really good if they're there and at every mission thread workshop, because they're the ones who are going to be taking a lot of the SOS architecture action items and rolling it into and start reasoning about what they're going to do with many of the issues that pop out. And it does require some strong facilitation, but we've had that experience doing ATAMs in the past over many years. We actually found that you know, a good OV1, a good vignette, and a good mission thread is pretty much all you need to get going on a mission thread workshop. And as I said before, it tends to end up normalizing the OV1s for the group, which is really a good thing. And from those, it's pretty clear how the OV2s, 3s, 5s, a lot of the variety of the next level down DODAP views really can be generated and driven by the outputs of the mission thread workshops. Another thing that came up pretty early was it's really good to start capturing what I would call the SOS architectural guidelines and precepts. And you could start doing that early as part of your SOS architecture plans, but they really start getting fleshed out during the mission thread workshops and some of the challenges. And we think that it's very beneficial to have the mission thread workshop outputs drive a lot of the architectural guidelines at the SOS level that are going to be imposed perhaps on the constituent legacy systems or some of the communications that happen. Like I said before, it was kind of surprising to me all the SOS capability and engineering challenges you can find by going through these mission threads and augmentation. It's an equal number. Actually, we found it's very consistent. Equal number of engineering considerations and gaps are identified during these exercises. One thing that we found beneficial was after each mission thread workshop, we generate some mission thread workshop specific challenges, whether they're architecture, engineering, or capability, and we vet those with the principals after every one so that we get agreement on what some of the action items are, what some of the issues are, and then we take a step back when we're done with the series and we roll them up into yet another level of challenges. And actually, I wasn't sure that second level of challenges was going to be a fruitful exercise, but it proved to be fairly fruitful when you really look at some overarching issues like resource management. You look at some of the other quality attribute specific architecture challenges that came out of each one. And it was a good exercise to do that. So I think that brings me to the end of my slides. The next step would be to go use many of the augmentations and use cases and questions from the mission thread workshop augmentations that pertain to a specific one or more legacy constituent systems from which you can easily generate scenarios that you can then do an architecture evaluation of that constituent system, not against the requirements it was built to, but against the expectations that the system of system architect has of it as it plays out in the end-to-end mission threads. So I think that wraps up what I was going to talk about.
Okay, Mike, thanks for your presentation. We've got lots of questions here, so folks feel free to time them in. We're not under a time crunch. We can have a good question and answer session here. Again, we had lots of questions during the event about slides and recording. The slides are actually in your console now, folks. You can download those items and walk away with them today. Recording should be available within a day or two. All registered attendees will get an email with how to access the recording on demand. And so let's get into the questions for Mike. Question 1 from John asking, what about resiliency as a quality attribute within the SOS architecture?
Yeah, that's a very good question, and we keep a very open mind about new quality attributes. As long as we can express those, and we can define it, and we hate to be splitting hairs about maintainability is modifiability, is separation of concerns. But we are very much open for resiliency or any other new quality attribute as long as it can be expressed, and we can actually have some good set of questions that we could ask during the mission thread workshop about resiliency. But no, I have no problem, especially if you're starting to prepare for a mission thread workshop and you look at those quality attributes on the table initially. It's all fair game, and I actually enjoy, and I think it's very fruitful to have those discussions about how would you characterize resiliency, and how does it play out in this SOS.
Great, folks. I want to give everybody a heads up as well. I'm going to push out a survey now that will pop up in another window on your screen. So we appreciate if you can fill that survey out before logging out today, as your feedback is always greatly appreciated. And that will be coming out now. And then on to the next question from Mike, from Sushant, asking, how are quality attributes, identification, and prioritization different for SOS and non-SOS architecture?
Well, so the quality attributes at the SOS level, I like to look at those as overarching quality attributes that are going to span across constituent legacy systems. And what we have at the software world, if you're familiar with the ATAM and QAW, they're very system software specific, and the end-to-end quality attributes that we've defined, that we've uncovered at the SOS level, really have a nature to them that we found is very good to capture in the mission thread workshop. And initially we weren't sure we were going to have a lot of overarching SOS new quality attributes or considerations or expressions. But when you start talking about, let's pick one, availability, you start talking about distributed resource management, and you start talking about how are all the different failover mechanisms going to play out from an end-to-end perspective, and how is it going to play out, or even from performance perspective, what is the end-to-end timeline? In their essence, they're really not that different from availability at the lower software levels. They just express themselves, and the scope of their applicability usually spreads out over many constituents' legacy systems. So we were surprised that we came up with SOS quality attributes that were really much different. So the big difference to me was the scope of their applicability across legacy systems, and how is it going to be played out when you have these very independent actors and systems and nodes, each with their own different way of looking at for example, availability. And there's a really good, I don't know how much time you want, I have a really good example of a SOS radar.
Please go ahead, yeah.
Okay, so one example that came up was very interesting. So imagine you have a radar sitting on a platform, And from that system and platform's perspective, if that radar goes out or there's an error or something, then from that guy's perspective, he's going to have to do his own fault tolerance, whatever they're going to do. But he's pretty much down from a radar perspective. But you take it up to the next level, and you've got a set of radars, and you could reconfigure. You can do some dynamic reconfiguration, for example. You might lose a little bit of that coverage that was in that one radar, but you can also reallocate some assets to go maybe get something that's not quite as high quality. So from an availability perspective, in that real simple example, you can see that SOS availability with respect to radar coverage is very different than the constituent systems availability on that same radar. And that stuff all gets played out very interestingly in how you do degraded modes of operation, how you're really going to handle radar coverage when something got damaged, but you're at the SOS level, and maybe you can throw another asset at it if that asset's available. So I don't know if I answered your question, but that's what came to mind.
So feel free to chime back in if you something more specific there. I know we're close to 4. Mike, if it's okay with you, we'll fire off a couple more questions.
Sure, no problem.
Okay. Question from Adrian asking, Mike, I realize the complexity resident in the Navy, but have you done any work with DODAF as realized in the Army, specifically JTRS or WINT?
Yeah, so we have done some work in Battle Command, and we've done the mission thread workshops in some of the Battle Command exercises that we were involved in. We actually did a system architecture evaluation of WINT. That was probably about 4 years ago. So what we did, the big one we did was with the Navy, but we've done, I hate to say the Navy one was any bigger, but we did a lot of mission thread workshop with the folks at PM Battle Command, and actually it was very interesting. They were starting to adopt some of the agile stuff, so we called them user stories, but they were actually end-to-end mission threads, and we went through the same exercise, coming up with different mission threads. We actually outbriefed on what we thought were some of the big architecture challenges facing them, and I didn't find anything that was nothing that really necessitated us to change the method just because we went from a Navy domain to the Army. It was pretty much went without any major changes.
Okay, great. I'm going to give you a double question here. The first one seems probably a quick answer than the second one. First one from Eric asking, what is OV6? And the second part from John asking, how do you deal with the different mission thread tiers, tier 1, 2, or 3, that are joint in nature within the SOS architecture? So first question, what is OV6? And then how do you deal with different mission thread tiers?
Okay, so the OV6, I believe you're stretching my memory here, but it kind of relates to the dynamic behavior. It's the state transition descriptions and the event trace transition. So when we talk about inputs to some of the OV6s, what we do is we start decomposing some of those steps that are relevant in some of the use cases that could feed into the state transition diagrams that the SOS architects really wanted to have for that SOS. So it wasn't all the inputs they needed for the OV6s, but it was a lot of the quality attribute state transition information that they didn't have initially at first, especially when you looked at availability and some of the other ones that really changed some of the states in the system. So it really helped create better OV6s from some of the mission thread workshop augmentations, especially in performance and availability. And what was the second question?
Yeah, I was going to say, let me repeat the second one because I was wrong. I thought OV6 was going to be something easy, but I was mistaken. So the next question is, how do you deal with the different mission thread tiers, tier 1, 2, or 3, that are joint in nature within the SOS architecture?
Joint mission tiers 1, 2. I'd have to find out more about what's behind that question, because I know that the joint there is a program we have not been engaged with yet that is looking at joint mission threads. And as a matter of fact, I think I gave a presentation 2 months ago, and someone was going to send me an invitation to attend some of their meetings. Unfortunately, I have not been tied into a lot of the joint mission thread work that's going on. I believe, is it OSD or someone? But I would certainly like to follow up with whoever asked that question, because unfortunately, I don't understand the different tier 1, 2, 3 mission threads.
Okay. Mike, we're going to go one more. I know we're a little past 4 o'clock. We'll go one more from Tony asking, how do you handle legacy systems that don't meet a given quality attributes but can't be easily replaced?
Yeah, so that to me is really a great question, and it really gets to this architectural mismatch. What we first want to do is identify specifically where the architectural mismatches are, and from there we have now a technical basis for which we can go to the program of record and say, look, we don't want to greenfield this. That's what I mean by kind of acquisition threads or acquisition activities. Here is the basis for which we say that there is architectural mismatch in the following areas, and how do we go about funding or writing a contract or doing the acquisition to get the necessary behavior we want, or what do we do at the system architecture level that kind of takes care of the mismatch in a way that doesn't perturb the legacy system if they come back with a huge bill saying, well, it's going to cost $50 million to make this. So what can I do with the SOS architecture? That's the information the SOS architects need to be able to reason about. Do we push back on the program of record to get the behavior, or do we maybe consider a different one? Maybe there's another version of that system out there that doesn't have quite the capabilities but has a better architectural match, and I can add some capabilities. Or thirdly, what do I have to do at the SOS architecture level to take care of this, if you could do anything? But the whole idea is to identify the technical basis and architectural basis to have a negotiation with the legacy contractor or program office.
Okay, Mike, I'm gonna see if we can sneak in one more if there's a quick one, because it's a really important question for a lot of the attendees. If it's not a quick answer, we'll ask Rika to send it in other methods. But any experience applying this to business enterprise architecture? Yeah,
I mentioned that earlier. We've worked on a couple enterprise architectures, and we have found that the notion of vignettes and mission threads holds water very well. I've personally done a couple where we actually took the business processes and we looked at it from an end-to-end perspective through the enterprise architecture and got the same results. There are some architectural challenges, there are some engineering and business process challenges, and I was pleasantly surprised at the basic engine of the mission thread workshop. If you take out the DoD type mission threads and put in end-to-end business threads, basically very little changes are needed to the workshop. The one experience I do have is that stakeholders, it's a very different, it's kind of a new world to me, a different world to me, working in the enterprise architecture world, which I've been doing last year. Getting stakeholders I've found to be a very interesting problem. The DoD is loaded with stakeholders at the government level who will give you many, many opinions. As a matter of fact, you got to sift through a lot of the good opinions versus the bad ones. The enterprise architect is usually a very smaller team, and we've had to have people do some role playing from the business perspective, and I was never comfortable with that. So one of the things I really want to make sure of is you really get the business folks and the stakeholders, which means you might have to go out to sometimes the user community and get their inputs. I was comfortable before having surrogates sit in because they have good surrogates, but it'd be actually better to have engaged the actual stakeholders. The big difference to me was finding the right stakeholders and not always using a surrogate at the enterprise level.
Okay, Mike, that's all the time we got. So thanks for your presentation there. We appreciate your time.
Oh, thank you very much. I really appreciate it.